like before, I am going to record this. I was able to get the camera on the screen today, but I can't have it here and on the big screen at the same time. And no matter what, the resolution is ass because it's a really, really cheap camera. So I'm just going to do it this way, and I'll kind of go back and forth between the stuff as needed.
So we use the red, black, brown resistor for the LED?
Yes. And then the brown, black, red, I've got a picture of it on the screen here for the switch. Yeah, this should be the right one. If you don't have it, I've got 4 left. So it's gonna start popping up there. So basically, you just agree to all the stuff. That's fine. And it'll ask you to install 2 or 3 things while it's doing this as well. Just say yes for all of them. Otherwise, it won't work. Say, and as you're building that circuit, again, the recording of everything that happens today in class will be right here if you need it, including the camera stuff. It's a little hard to see, but I do have the diagram worked out here. I'm going to be switching to the kind of smaller hold your shape kind of wires, just so it's not a big mass of things and you can see it. If you have the code from last time and it's all hooked up right, you should, when you press the button, see the light turn on. But again, I'll walk you all through that part. It is currently 1:19, so in about 3 or 4 minutes, just for the sake of time. There you go. I'm going to add an extra day of this stuff. All right. That's going to be 10,000 on the chart. For these blue ones, the colors are going to be brown, black, black, red, and then probably brown at the end. But again, you should also have the chart that'll be helpful for that.
So brown, black, black, red,
No. I think you have that one backwards. Because I don't think red is used for a tolerance. At least not in the ones we normally have. Like I said, if you don't have it, I've got a few extra, but I've only got 4 left, so.
Is this one of them?
They look like this. So again, it's,
I don't know.
Did I get that right? Yeah, so it'll be, actually, I think that might be the wrong one. Yeah, this is one for a light. They look like this. So you see how it's brown, black, black, red, and then whatever. Yeah, and then I have one of the brown ones, but it's the same thing. So, and then if you don't have it, these things are really cheap. So I mean, you can grab them. The what's?
Brown, black, black, red, red.
No, brown, black, black, red, and then I guess technically brown on the end.
Is this the one that we need?
Not quite. This one is. Where's my little chart? 100. This one is 1,000, not 10,000. It might work, but it's a little small. You want it. You see how it's got brown, black, black, brown.
Yeah.
This one's got brown, black, black, red.
Okay.
So if you can't find it, I said I've got 2 left. So if y'all want it, if each table wanted to share this particular one, we can. But again, you need for this particular circuit, Arduino says do a 10,000 ohm. 10,000 ohm is the big one that you were asking about, and then 220 ohms is the one for the light that we've been using. It's going to look like this. So it's going to be brown, black, black, red, and then probably brown for your last one. But the last one doesn't really matter.
I like that brown, black, black.
If you've got it, that's great.
Like this, but it's like kind of red at the end.
Let's look. I think this one is going to be this way instead. So it would be red, red, black. Because usually there's not red on the last one. So I think this one would be the. What would this be? 220 times. This would be 220 ohms. So this would be something you could use for a light potentially, but not this one. So you only want one red. Yeah. If like I said, if you don't got it, I've got 2 left. I might be able to find one more in my box. I honestly don't know how many of them I have.
I think I found it. Is this it?
No. These are brown, brown, black, black. So this would be 100. This is like 100. These are a little smaller. So I'll tell you what. Grab one of that. You can use that one for the switch. Let me see if I've got any more.
Yeah, I don't have the 10,000.
Yeah, that's okay. Some kits come with a lot of good resistors. Some do not. Okay, I think you're one. No.
And where is this one going?
All right. So, do you have the picture pulled up on the computer? So, you've got it on your switch here, your button. You've got power coming in on one side.
It's going to be this back one.
It's going to be this one right here. So you've got power coming in on one side of the button, and then over here the resistor going to ground on the same side, and then on this other side diagonally from the red, you go back to the board.
I don't have that resistor. Thank you.
You're welcome. All right, there's one. No. This is not the best system for organizing these. Oh, there's one. You are hiding. Way the heck down there. Alright, does anyone else need the resistor? I found two more. Okay, you can help yourself to either of those, they're the same.
Thank you.
You're welcome. This was brown, black, red. Are you one? Brown, black, orange. No, that's 100,000. That's too big. And that's backwards. Alright. That's about all I can find right now. So like I said, I've got one more resistor for that switch. If you need it, you can grab it, but don't lose them. Make sure they get back in your box. I need a better organizer for all my resistors, but that's what I can find right now. I'll keep this extra one right here. Okay. So for the sake of time, I'm going to keep moving. I'm going to, again, walk you through this circuit. So hopefully, if you're not quite done yet, you'll be able to catch up. So, again, I've got this also built up here. So again, the resolution's kind of gross, but at least it's something. So if you watch this on after the fact, you should be able to see it. But what we've got is coming from the 5-volt and the ground are just connected to the breadboard, the plus and minus. If you've kept those wires I gave you on the first day here, these should just connect to the other side. Just so that way both the in this case top and bottom are hooked up to power. So that's there. That's the easy part. So the next bit, I guess I'll start with the LED because that's also the easy one. So if you hook up the LED from pin 7 of your Arduino, if you start down here and just kind of 0, 1, 2, 3, 4, 5, 6, 7, it should be the last one on this little grouping of pins. But that goes to the positive end of your LED, the slightly longer wire. Connected to out of the shorter wire will be your resistor. This is that smaller one, the 220 ohms. And then that just goes back to ground. In this case, the negative row here on the breadboard. That's all right there. Where this is different from what we did before is if it was hooked up to the plus here, the red, the light would just turn on and always be on. But we want to be able to control whether or not it's on. So we're going to only send the current down this purple wire when we want to turn it on. The way we're going to check that is with this half over here. And what that is going to be is we're going to connect the positive to one end of this button. And then on the same end, again, so we haven't jumped across this gap yet, but on the same end, we've got the big 10K resistor right here, and that just goes right to ground. All right, what this does is it makes it so that current doesn't flow through when we don't want it. It always pulls it back to ground. Once you've got that side wired up, all that's left is to connect up the other side of this button to pin 4 on the Arduino. And you know you'll have the right one if from the power you go diagonally across the button. That's how these work. So again, plus diagonally into pin 4. So now when we click the button, kind of how I'm doing here, the light will turn on. Almost. Question? Okay. I ran into that a little before. Make sure you're plugged into ground. I ran into a bit of that. Just like all the pins on the board are correct. I'd have to come look at that in just a second. Yes. All right, I'm gonna come around and look. You may not have this working if, for whatever reason, your Arduino has a different code, because we have to program our circuit board to actually do the things correctly. So we want it to be able to check the electricity coming in to pin 4 and then output the electricity coming from pin 7. So I've given you code right here that does that. This is what we ended class with. So if you just copy all, I didn't have the bracket there, but if you just copy all of the stuff that I'm not even going to worry about it there, what you can do is then paste it into the Arduino program. It's just going to be right here. Again, to go through it, we are setting pin 4 and pin 7 to be the ones that we're using. You theoretically could use any of them, but I just picked 4 and 7 this time. And then the button state. In setup, we're saying that the button pin is going to be an input, so we're going to be getting electricity from it. The LED pin will be an output, so we'll be sending electricity out of it. This stuff down here is a different thing that wasn't in your code, but basically you could set it up so that way you can see it responds. So 0, it's off; 1, it's on; 0, off. But we don't need to get into that right now. I was doing some troubleshooting. Then in the loop function, the thing that happens over and over again, we're just saying, hey, check what's coming in from the button pin number 7. If it's high, write out the LED to also be high. Otherwise, put the LED as low. So the light should only turn on when you press the button. Once you've pasted it, be sure to hit the upload button to actually put it onto the Arduino. So you gotta hit the upload and it'll go through. And go. So I saw a few people were having some technical difficulties, so I'm gonna work my way around before we get into the next part. You shouldn't have to close on that. So you just copy and pasted.
Oh, okay.
So hit the upload. Serial port not selected. Where do we have, where's the serial?
This is upload.
Yes.
That's
Serial port. Okay, go ahead and, let's just go ahead and do that then. Just save it. Just do it on the desktop or whatever. Doesn't really matter. Okay, uploading, okay, serial port, go ahead and hit OK right there. Basically just want to make sure I can find the thing. Uploading, done uploading. Wait. Okay, so let's look. 5-volt bridge, so from here, make sure we're in the right spot. Pop loading, to make sure everything is. No, you just have your LED backwards. So a diode, an LED is just a light emitting diode, only lets electricity flow through it one way. So the longer end, that's the positive facing pin. So the stuff coming from positive, in this case your red wire, needs to be first. Yeah. And the shorter one will be what's going towards your resistor back to ground. So you got it, it was just backwards. That happens. I do that a lot. Because I was working my way around, so. This is that. So let's see what. Yes. Let's see. 47.
Oh my god.
I don't think mine does that.
That was my friend. He sent me something.
And you put the code through Arduino. Okay, so then hit upload, just to make sure it's on there. Okay. So let's look. So here, okay, that's in right. No, that looks. This one's gonna want to be in the negative. Let's see what happens. Nope. Just do something else. Yep. It might be, let me. I think this is the wrong number. Let me just grab you one. Yeah, it doesn't look like y'all's kits came with the 10K. So maybe just have to share. I think this is my last 10K. That's okay because we only need it for this part. So we want to go straight to ground. Okay, that's right. So let's see. So this is the ground, goes to negative. And then this one goes to positive. I'll try to get it backwards, right? And this one is also backwards, so you want that to go to negative. So we have the positive and negatives backwards, but that should be. Let me come over on this side. Oh, you have to like plug it in the right hole. This one. Going to pin 0, 1, 2, 3, 4. Here. Go ahead and go back into Arduino real quick. I'm going to add something to the code and we can check it. So just go ahead and click into setup. Which inside the brackets. Yeah, so I'm just going to type it through. Of course it does. Like with everything.
This is no. But it's also kind of
On button C, not button 2. Oh, I think I'm missing something here. Is this the one you copied out of the Google Classroom? Let's go with the one for today. I think I fixed a typo that was happening. Okay, that was easy. It was in code issue that way. Basically, this, it was detecting this, it just wasn't storing it in a variable to turn the light on. So, yeah, that and just the slight little plus minuses, but you get it. Alright, I know I saw one more hand over here. Let's look. Okay, yeah,
they're gonna start getting near the research. I tried to explain that kind of looking after that.
Okay.
I'm trying to just
Yeah, that's just it's getting data stuff, so we can move these over here so they work slightly that way. So we get I just made it wrong. So it was these ones, and they weren't lined up with the resistor correctly, I think. So again, it's the way it's lined up right now is these vertical ones are all positive. And then you just have to make sure this one's going to positive and this one's going to and now it seems like it's is anyone else not able to get their button to turn on the lights? If not, we're going to move on to the next bit, which will be a little bit easier. but it's kind of just the next step. Okay. So that was, again, just using a button to trigger things. And really the concept of this is what's important, not the fact that we have a button doing the things. Actually, we don't even need that one any there. This is just having some way to monitor an input and respond to it. So again, in this case, we're just monitoring whether or not the button is pressed. We could do it with a switch like this, if you're watching the video, or I'll hold it up in just a second, but a switch. It could be something else entirely. What we're going to wrap it up with today in the next 30 minutes is being able to control the speed at which this light turns on and off. And we're going to do that with what's called a potentiometer. So if you're on the textbook, I recommend going through here. We're going to go through the lesson I wrote and am now testing out for the first time on all of this. Well, we'll find out if it doesn't work. That's what we did last class. So up until this point, we've been using some digital signal. And if you've noticed, the thing with the digital signal is it's either high or low. It's 1 or 0. It's off or it's on. That's that. Which can have its own useful applications. However, you may not always want that. Sometimes you'll want something with a range of values. If we're using the light thing, what we'll be doing on Tuesday, that's the next time I see you, we'll be essentially being able to add a dimmer to the LED by combining what we do today with what we did Tuesday. But again, I'm going to get ahead of myself, so we're not going to get into that. But what we're going to work with now is working with analog signal. And again, an analog signal has a variety of values. It can be multiple things. The Arduino board is going to pick up various values between 0 and 1023 that we can then map to be specific things. What we're going to be using, I'm not going to get too crazy into this, and the way we can kind of work with this is with what's called a voltage divider. And basically, if you have two resistors in a circuit, you can check the difference between them. So as you change one, it changes the amount of output signal. So basically, if you have, looking at this, let's look at this second one here. The current's going through. As you change the resistance of this first resistor, the amount of voltage here is different. So by increasing it, you decrease the voltage, and so on and so forth. And that's written out in this equation. I don't think we need to know all that in super fine detail for this class, but it's something I've included here if you would like to look a little more into that. What we're going to be using to create some of these things are potentiometers. All right, they're abbreviated as POTS. Don't Google pot on these computers; they get mad at you. But if you ever hear someone referring to a pot when they're talking about this kind of stuff, this is what they're talking about. This is it's what's called a variable resistor. So by twisting the knob on your potentiometer, you will change the amount of resistance running through the leads. I think most of you have this big one right here, big being the relative term, but it looks kind of like this. I personally like the little tinier blue ones just because they don't take up as much space, but we're going to use what we have. There's some other kinds as well. I'm not going to go through it all because we don't have them. But basically, anything that can change the amount of resistance like this is a potentiometer. There's some really small ones that you have to get a screwdriver to change for really fine-tuning things. You can also find them is kind of like a straight dial, kind of like basically a dimmer switch. That's what a potentiometer is. What we're going to do is wire one up in order to control the speed of our light. Right? So I've got this circuit right here that I'm also going to build. It's going to be very similar to the one we just did, but it's going to be a little simpler. Okay? So we're going to start with the circuit and then move into the code. You'll notice you don't need that 10K resistor. So if I gave you the resistor, don't lose it. Just put it in your box somewhere, because again, your kids didn't have those. We don't want to lose them. I'm going to take out my button because we don't need the button anymore, and I'm going to put in my potentiometer. I'm going to use the small blue one, just because it shows up a little bit easier on video. Obviously, if you don't have those, you won't use them. These big ones will fit in the breadboard. You may just have to mash it in there a little bit. They get in there. Actually, you know what? I'll use the same one just so it matches. So we're going to stick that in. You'll notice that there are 3 pins on the potentiometer. Okay, and you may have to, again, kind of tweak this to make them all line up, but that's okay. The outer pins get connected to positive and ground. Unlike an LED, electricity can flow through a potentiometer in whichever direction you want. So it doesn't particularly matter which way it's facing, but you want to have I'll say the left lead connected to positive and the right one connected to ground. What you're going to want to do then, I think that's the easy part because you have the stuff from your button still there, is go in and take what was connected to pin number 4, again the one from the button, and that's going to be connecting to your middle pin of the potentiometer. All right, and that's going to go into pin A0 on the Arduino. So again, I've got this diagram right here that you should see that. So it's, again, positive goes to one side, negative comes out the far side, the middle goes to A0. Everything else so far is going to be identical. We're not even going to touch the part with the LED. If you just leave that exactly how you had it from the last circuit, you'll be fine. Give everyone a second. Yes. You shove it in there. I'll come by just to make sure, but again, it might be a little tight, but it will fit. So keep in mind, with these potentiometers on the breadboard, there's going to be an empty connection hole in between each pin. So it takes up 5 wide on them.
Does it matter where the analog wire goes?
The analog wire goes to the middle pin. So you're going to want it on this side. So you may need to move it'll probably make your life easier if you just pop it out and do it this way. And then you can see again the analog one goes to the middle pin, and then it's just positive and negative on the others. All right. Give everyone another few more minutes. just so we can at least get to the end of the potentiometers and talk about sensors. Um, yes. Yeah, yeah. So this one didn't have, when I made this diagram, it didn't have the same looking potentiometer, but it's that. So you get the thing that looks kind of like a gear, and it just, you may have to get a little forceful with it, but you just shove it in there. Not particularly. Really, again, you can, especially with these bigger ones, you can really force them. So again, the middle pin, you're going to want to be on, actually this will probably make your life a little easier, just so you can see what pins are there. Middle one, I think it's this row, right by the end of my finger, that goes to A1, A0, and then the other ones, one goes to positive, one goes to negative. It doesn't really matter which one you're using. Sorry, check and see. Okay. This is the same kind of idea, but it's got, unlike the potentiometer, it's got like clickable states. This one's just overriding. So you got it again. All right. You can get back here. Awesome. All right. Once you're done with that, again, I'll give it another minute or two, but if you scroll down, I have a screenshot of some code. You're going to want to open up a new Arduino sketch, and you want to have these contents in here. You can just save it if you want. But again, we're just gonna. So again, once you've got your potentiometer wired up, I'm just going to go to File, New in Arduino, and that's going to open up this new editor. And this code I have right here is what you want to have inside. I mean, it's going to be pretty simple. I did it this way so you get practice typing it out in Arduino. Equals. Okay, one thing that is different, if you use LED pin equals 13, you're going to have to move your pin from pin number 7 to pin number 13. I'm going to use 7, just so I don't have to change that on the circuit board. Just keep that in mind. Oh, and Chase, just because you weren't here last time, make sure that it's formatted exactly. Arduino is not very forgiving, so if you forget a semicolon at the end of the line, it won't work. Yeah, it's annoying. I've done it many times. Okay. Did I do it this way, actually? No, I didn't. That's okay. So it looked like most people were getting their potentiometers worked up just fine. So I'm going to talk about the code, and that's not the one I wanted. Did I close it out by mistake? Yeah, no, go back. I wanted... You know what? You're just making me angry. All right. All right, so this is basically the exact same code. I've added one more thing just so I can show it off, how this is working. But like we've done so far, we are setting some pins. Again, the analog pins are separate from the digital ones. You'll notice there's a lot less of them, and they're only input pins. Okay? So they say analog in on the board themselves. You can specify it just by saying it's A0 through 5. The LED pin is the same. Sensor value is just going to start off at 0. Pin mode, just like before, we're going to set the LED pin to output because we want to check the sensor and then output electricity when we tell it to. I'm going to come back to the serial stuff. And then down here in the loop, we're going to check and see what the value coming in is. And then we're going to write the LED to high. Delay pauses the loop for a certain amount of time. So we're going to turn it on to high, wait a bit of time, turn it on to low, wait a bit of time. So as this sensor value increases and decreases, the amount of time between the LED turning on and off will change. These two lines I've added here, serial.begin and serial.print, basically says in the serial monitor, it's going to come up with, why is it doing it this way? That's annoying. I want it to be vertical. Oh well. Basically, this is the data that's coming in through the USB cable, and this will be more important in the final unit of all of this when we make it talk to the P5 code. But as I twist this, you'll notice that if I go one way, it's 0. Again, I don't know why it's not. Do it vertically. I want it vertical. Carriage return. No. God, that's just so horrible to watch. Oh well. Yours, ideally, it should be making a vertical line, but you'll notice as I twist this, in one way it's 0, but as I increase it, the number increases, and it's also moving slower. Same thing with the LED blink speed. The highest one we get here is, looks like 1661 is kind of the highest. So again, the various potentiometers might be different. Yours might change, but you'll notice that turning it one way should slow it down. Turning it the other should speed it up. What I want you to do is then take out your potentiometer, twist it around, and put it in backwards. You'll notice that it's still going to work, but now it's, again, twisting it the other direction has the same effect. So if you twisted it to the right before and it sped up, now if you twist it to the left, it'll speed up. So again, this is just showing that electricity can flow through this in both directions. So we have that there. Again, what we'll be doing on Tuesday is a similar thing, only with digital values. And we'll be playing with something called pulse width modulation. It's not nearly as complicated as the name makes it feel like, but we'll be using digital values in order to do the same thing, also with a potentiometer, with the idea being that you can turn it off and on too fast for you to see, but it'll affect the brightness. You can read about it in the textbook if you want to over the weekend, but that's what we'll be getting into from there. And then if you just happen to see it, potentiometers, sometimes they have, like if you touch them, they'll do things. They have a bunch of different shapes. What I want to get into with just the last little bit, we won't be making any code because we only have like 7 minutes before you should start packing up your boxes. But I want to see if you all have any sensors in your kit, because this is the next thing. So do you have something that looks like this? No.
Mine's not wanting to work.
I'll come back in a second. Yes. Yes. All right, so it doesn't look like we have those. These are light sensors. They respond to the brightness of light. Okay. I know for a fact you don't have any of these because these are expensive. I don't think you have a distance sensor, but you might if you have something that looks like this.
I don't think we do.
Okay. Maybe, I don't know if you'd have a tilt. Looks kind of like a black cylinder, and if you shake it, it rattles. That's a diode. It's not a thing. I know you don't have flex sensors because they're expensive, and you probably don't have a temperature sensor, but that's okay. I have some sensors. Well, you might. That might be one. There's a lot of stuff that looks like that, actually. Might be one, but it's going to be kind of hard to do our thing, so I want to adjust it. These have different things in the same shape. I'm just going to look in the kit and see what we have actually. I was just given these by. Okay. That's okay because I do this kind of thing for school. So let me see what kind of sensors I've got. So I want to have next class be a mix of sensors and pulse width. Okay, I've got a distance. I've got a pressure. I've got tilt. We could potentially use the microphone. Okay. So I'll hand these out on our next class, but I've got enough sensors for us to use. So I've got a handful of those light sensors, and then a pressure sensor. Someone could use the distance and potentially the tilt. But that's what we'll be focusing on next class is pulse width and these analog sensors. It may just take an extra day to get through it, but that's what we'll be going from there. So, Chase, were you able to get yours working? Let's look at that real quick.
Should we start everything exactly except for this is only at the top.
Okay, if you're able to adjust the speed of your light, then yeah, we're not going to build anything else today. Okay, let's see.
I already tried to
What did you think? working here on the built-in LED, so that shows you, so as you turn this up, that's the one that's going. So why this one isn't? Oh, that was just one off. Okay, since it's 13, these will both do the same thing. So now as you turn it one way, you'll notice that when you turn it all the way, it's doing it too fast for us to see, so it becomes like a solid light, and that's going to be the core of what we do on Tuesday. As you twist it one way, it should slow down because we're just getting the number and setting that to be how long we want to delay. Alright. Hopefully this is starting to get a little easier as we do it more and more. And we're working through all the stuff. I'm going to stop recording now.